Lindsay Ejoh, learning to relieve pain in a drug-free way.
Did you know your experience of pain, as real and frustrating as it may be, can be heavily influenced by expectation? This is a version of the placebo effect, and I'm going to prove it to you by taking a couple steps back in history to World War II, where a war medic named Dr. Henry Beecher was treating injured soldiers on the Italian battlefield. Dr. Beecher used morphine, a powerful and effective painkiller, to treat these soldiers. But unfortunately, he had a limited supply and eventually ran out. But he didn't give up. He had a trick up his sleeve. He decided to not tell anyone he ran out of morphine and instead give his soldiers a saline solution instead to treat their pain. And remarkably, 50% of those soldiers reported pain relief from what was essentially just a saltwater treatment. This is a version of the placebo effect called placebo analgesia, or placebo pain relief, in which the expectation of pain relief can actually lead to a reduction in pain perception. You might wonder, is this something that is only in your head and imagined, or is there something actually going on in the physical body to make this happen? Amazingly, when you expect pain relief in this context, your brain makes and releases neurochemicals that talk to pain neurons and tell them to shut up. Some of these include your body's naturally made opioids, like endorphins. These endorphins primarily act on pain neurons in your spinal cord. They shut them down, and that blocks the pain information from reaching to the brain, therefore blocking your perception of pain. And if pain information can't reach your brain, did you really feel it? On the other hand, you might hear about another popular opioid, morphine, like I said before. This works by bathing all the opioid-sensing cells in your body with this opioid, and the result is shutting down a lot of brain cells and body cells that can't really afford to quiet down. It can act on your brain's mood, reward, and addiction centers, or even some of your internal organs like your liver, your gut, causing constipation, or even your ovaries and testicles, or the muscles that you require to help you breathe. On the other hand, this placebo pain relief effect is special in that it's very controlled. It has very tiny amounts of opioid release, of your natural homemade opioid chemicals at very specific parts of the nervous system so that you can get pain relief in a way that doesn't lead to these other harmful side effects. Get that. Your body's own opioid system can help treat your pain. That's why it's so important for doctors and other clinicians to communicate positively with their patients about their pain treatment outcomes. And in situations in which they don't communicate enthusiastically, it can severely affect the treatment outcome. So you might think, all right, I want this for myself. How do I get pain relief without side effects? Some people are more likely to have it than others, and it only happens in specific situations. So, for example, if you've had experience taking a particular drug before, you know that you've built this expectation that it works for you, it's more likely that the next time you take it, you'll be able to engage with this natural opioid process. On the other hand, it also works when you're taking similar types of drugs. So if you get a shot and you know that in the past, shots have helped you more than pills have, it's more likely that you're gonna have this placebo pain relief effect just because you're taking a shot, regardless of what's in the vial. Also, some people are more likely to be placebo responders. So for example, if you're more susceptible to hypnosis, you're more likely to have a placebo response. Also, people who scored higher in agreeability and resilience in personality tests. And people also have differences in their brain's opioid and dopamine systems. Scientists are working to hack these placebo circuits so that we can really understand what goes on during placebo pain relief. Because unfortunately, just because you've had a placebo effect before doesn't mean you're going to be able to have it again. It's pretty unreliable, but that's okay because we can still study it and we can still harness it. For my PhD project, I'm looking at how cells in the nervous system react to this natural pain relieving process, and I'm doing that by investigating in mice. Because human brain scans can only tell us so much. So you might wonder, how are you gonna get a mouse to have a placebo effect if they don't understand English, or French, or a doctor's messy handwriting about whether a treatment is gonna work for them. We do this by teaching them to associate pain with specific environments and pain relief with others. In the lab, we use a 2-chamber maze to achieve this. As you can see, both chambers have completely different visual contexts, and the animal is able to move freely between the two. And they're lined with temperature-adjustable hot plates. So what we do is we teach mice to associate the right side of the chamber with a hot temperature and the left with a regular room temperature. And after they learn that the right side is hot and the left is not, we do something else. By the way, they're able to move freely between the chambers, so they always start on the hot side. Imagine you're in the clinic, you're in pain, you perform an action to get yourself to the safe side, and you learn that now that I'm here, I can experience pain relief. Afterwards, we make both sides hot. And what happens is we find the animals, even though both sides are hot, will prefer to be in the chamber that they've learned is safe and will exhibit less pain behaviors there too, even though they're still receiving hot plate pain, pain action. And just so you know, the hot plates are definitely uncomfortable, but they're not enough to damage the skin or cause any redness or anything like that. So we're able to teach the mice to expect pain relief in specific contexts. Previous models have done this with morphine, in which they've taken mice that have chronic pain, for example, a nerve injury, given them morphine in one of the chambers and a plain saline solution in the other chamber, and have also found that they're able to exhibit this placebo response. But our model is pretty special because we can have them relieve their own pain in a completely drug-free way in order to study these natural opioid processes without the addition of all these other opioid drugs. So we're interested in how the brain is encoding this process of natural pain relief. And we're doing this by using special sensors to, 1, track natural opioid release in the brain, and 2, track pain activity of these pain neurons. Amazingly enough, we found that as natural opioid release is happening, at the same exact time, pain neuron activity is occurring. So this is proof that with our assay, we're able to watch the animals experience pain relief and track their opioids as well. As we uncover and unlock the mechanisms of the placebo effect in the brain, we're reminded that the mind and body are far more connected than we could have ever imagined, and that the future of pain management may lie in unhacking your body's natural opioid system, bringing you towards and bringing us all towards making safer and more effective therapies for people living with chronic pain. So, I don't know, maybe these natural painkillers are gonna enter mainstream medicine, but we do know that we're out here to help you. Thank you so much.